In this video, we are going to look at the question 4s for the CSEC math exam for the years June 2022 to 2019. So here we have question 4 for June 2022. We have functions f of x is equal to 5x plus 7 and g of x is equal to 3x take away 1. Now for the functions given above, we want to determine for part 1 what is g of 1/3. So that simply means we're going to substitute 1/3 where x is in the function g. So we're going to write g of x, which is equal to 3x take away 1. And as I said, where the x is, we're going to replace that with 1/3. So we're replacing 1/3 here and here. So we're going to have g of 1/3 is equal to 3 times 1/3 take away 1. So now this 3 times 1/3 simply means 3 over 1 multiplied by 1/3. So that will look like this. 3 over 1 multiplied by 1/3. And then we're going to take away 1. So we can clearly see that this 3 will cancel this 3. So we have 3 into 3, 1. 3 into 3, 1. And of course now we multiply across, right? So 1 by 1 is 1 and 1 by 1 is 1. So this whole thing will just give you 1. So what we'll get here is 1 take away 1, which will be equal to 0. This 1 came from here, and this negative 1 came from here, negative 1. So now for part 2, we want to find f inverse of negative 3. Now before we could find what is f inverse of negative 3, we need to determine what is f inverse x. So I'll write to find f inverse x. Alright, we're going to let y be equal to the function f of x, and the function f of x is equal to 5x plus 7. So I'm going to have y is equal to 5x plus 7. Then we're going to interchange x and y. So this is just my little symbol for interchanging x and y. So where y is, you put x. And of course, where x is, you're going to put y. So that's 5 times x. So we're going to have 5 times y. So that's the interchanging of x and y. And now we'll transpose for y. So I'm going to write transpose for y. I'm just going to write over the equation. Alright, and now I'm going to transpose for y. So what we mean by transposing for y is that we want y to be the subject of the formula, which means we want this y to be by itself on one side of the equal sign. It could be on the left-hand side or the right-hand side, but the y must be by itself and everything else must be on the other side of the equal sign. So the first thing I could transfer across is this positive 7, and when I transfer it across, it will turn to negative 7. So I'll have x here that's already on the left-hand side, and I'll bring across the positive 7, I'll turn to negative 7. And then the 5y remains on the right-hand side. And now we have this 5 multiplied by y. So when I transfer the 5 across the equal sign, the opposite of multiplication will take place, and I'll get x take away 7 divided by 5. So I'll have x take away 7 divided by 5 is equal to y. And now this function x take away 7 divided by 5 is your inverse function for f. So f inverse x is equal to x take away 7 over 5. So now that we have the inverse function for f, we could find out what is f inverse negative 3 by simply replacing the x's with negative 3. So let's write it over on the top here. F inverse x is equal to x take away 7 over 5. So I'll have f inverse negative 3 is equal to, replace the x with negative 3, so negative 3 take away 7 over 5. So negative 3 take away 7, you add and keep the negative sign, and you get negative 10. So you'll have negative 10 over 5, and of course 5 we're going to 10 2 times, and you're dividing up negative with a positive, so you're going to get negative 2. And that's your answer for f inverse negative 3. Now for part B, we have the line L shown on the grid below. So that's the line L here. And we want to write the equation of the line L in the form y equal mx plus c, where of course m is a gradient and c is your y-intercept. So the first thing we could get here is the y-intercept because that's where the line touches the y-axis. And we can see the line touches the y-axis at 1. So let's make a little x here. This is our y-intercept. So far we know that c is equal to positive 1. The next thing we need to know is what's m, the gradient, which is your change in y over your change in x. So what I could do is make a little triangle under the line. And of course, I want my triangle to be more than half the line. And of course, I'm going to choose points where I could easily read off, what's the number on the x-axis and the y-axis. So it's easy to read this number off here. This is y is equal to 1 and x is equal to 0. And this number here is y is equal to 3 and x is equal to 6. So for my change in y, I'll simply count the blocks. All right, we have 2 blocks here. My line is sloping upwards, so I know I have a positive gradient. All right, so my change in y is equal to 2, positive 2. So then I'll count the blocks here for my change in x, which is from here, 1, 2, 3, 4, 5, 6. So my change in x is equal to 6. So now my gradient m is equal to my change in y divided by my change in x. So m is equal to 2 divided by 6. And that's because my change in y is 2, so that's the 2 here for change in y. And my change in x here is 6, so change in x down here, which is 6. And of course, we can say 2 into 2, 1, and 2 into 6, 3, so that'll be 1/3. So we'll have m is equal to 1/3. And now we can write the equation of the line L in the form y equal mx plus c by replacing the m with 1/3 and the c with 1. So let's write it over. Y is equal to mx plus c. And now I'm going to replace the m. So m is 1/3. So we have 1/3 x plus c, and c is positive 1. And now this is your equation of the line L. So let's write it out that the equation of the line L is y is equal to 1/3 x plus 1. So for B part 2, we have a different line, which is Q, and its equation is y is equal to negative 2x plus 8. Now here we want to write down the coordinates of the point where Q crosses the x-axis. So that's what we call the x-intercept. And to get the x-intercept, that's when y is equal to 0. So I'll put for the x-intercept, y is equal to 0. So I'll have y is equal to negative 2x plus 8. And we put y is equal to 0. So we have 0 is equal to negative 2x plus 8. All right, and now we just solve for x. So what I could do is transfer this positive 8 across the equal sign. I will turn to negative 8. And of course, 0 is nothing. So I'll just have negative 8 is equal to negative 2x. And I've seen that this negative 2 is being multiplied by the x. When I transfer it across the equal sign, the operation will change to division. So I'll have negative 8 divided by negative 2, which is equal to x. I'm dividing two negative numbers, so my answer will be positive. And of course, 2 into 8 is 4. So I'll have positive 4 is equal to x. So this is your x-intercept, positive 4. Now, how do you write that as a coordinate? The x component of the coordinate would be 4, and the y component would be 0. So that will be 4, 0. So I just wrote here that the line crosses the x-axis at the coordinate 4, 0. Now for the second part of the question, we're going to write down the coordinates of the point where the line Q crosses the y-axis. Now that's the y-intercept. Now the equation of the line Q is y is equal to negative 2x plus 8. And this is in the form y equal mx plus c. So negative 2 is the gradient, which is m, and positive 8 is c, which is the y-intercept. So it's very easy to get this answer without doing any working. But I'll still write down for the y-intercept, x is equal to 0. So I write out my equation, which is y is equal to negative 2x plus 8. And of course, if we put x is equal to 0, we'll have negative 2 times 0 plus 8. And of course, any number you multiply by 0, so this negative 2 by 0, the answer will be 0. So we have 0 plus 8. So y is equal to 8. And that's how you get your y-intercept. And of course, writing it as a coordinate, the x component of the coordinate will be 0, and your y component will be 8. So that will be 0, 8, and that will be a y-intercept. So I just wrote out here that the line crosses the y-axis at 0, 8. Now for part C, we have on the grid on page 14, which was this grid paper here, we want to draw the graph of the line Q. Now remember, for the line Q, the x-intercept was 4, 0, and the y-intercept was 0, 8. So with the x-intercept being 4, 0, it simply means the line touches the x-axis at positive 4. So I'll just put a little x here at positive 4 for the x-intercept. And the y-intercept being 0, 8 means the line touches the y-axis at positive 8. So I'll just put a little x here by positive 8 for the y-intercept. And now what I'll do is take my ruler and draw a line connecting this positive 8 here with this positive 4 here. And I'll call this line Q. So here we have line Q intersecting with line L. Now for part 3, we want to complete the statement below. According to the graph, the solution of the system of equations consisting of L and Q is. So what they're asking for here is the solution of the simultaneous equations for the line L and the line Q. And that will simply be where the line Q and the line L intersects. So that will be this point here. And the coordinate of that point here would be, we have 3 on the x-axis and 2 on the y-axis. So that will be 3, 2, the point of intersection. So I just wrote out that my point of intersection was 3, 2. So hence, we'd have x is equal to 3 and y is equal to 2. And that's because the x component of our point of intersection was 3, so that's why we have 3 here, and the y component was 2, so that's why we have 2 here. And of course, this would be the solution of the simultaneous equation consisting of the line L and Q. So moving on now to question 4 for June 2021, we have the diagram below shows 2 lines, L1 and L2. So this is L1 here and L2 here. The equation of L1 is x plus 2y is equal to 10. So we have that here, the equation of L1. The line L2 passes through the points 0 and negative 5. So this is the point here where line 2, L2, cuts the y-axis. And we're saying that L2 is perpendicular to L1. So the angle between L1 and L2 is 90 degrees. So let's put that in here. So this is 90 degrees here. So for part 1, we want to express the equation of line 1, which is L1, and we have the equation of L1 in the form y equal mx plus c. So since we already have the equation of line 1, all we have to do is make y the subject of the formula, so we can put it in this form, y is equal to mx plus c. Alright, so for part 1, we're going to write the equation that we were given, x plus 2y is equal to 10, and now we're going to transpose for y. So I'm going to transfer this positive x across the equal sign and return to negative x. So I'll have 2y is equal to 10, take away x. Then I'll transfer this 2 across the equal sign, and since it's 2 multiplied by y, when I transfer it across, the operation will change to division. And I'll have y is equal to 10, take away x divided by 2. Now what we'll do is write these 2 terms in our numerator over our common denominator. So I'll have y is equal to 10 over 2, take away x over 2. And of course, 10 over 2 is equal to 5. So we'll have y is equal to 5, take away, and what I could do for this x over 2 is write this as a half x. And now seeing that we want the mx first and then the c, I'll write this negative a half x first and then the positive 5. So I'll have y is equal to negative a half x plus 5. And that's the equation for L1 in the form y is equal to mx plus c. Now for part 2, they want us to state the gradient of L1. So this is the equation of L1. And as long as you have y as the subject of the formula, the number in front of x would be your gradient m. As you can see, y is equal to mx plus c. So what's in front of x is m. So this negative a half is m. And that would be a gradient. So I'm going to put m is equal to negative a half. All right? That just means your gradient of L1 is equal to negative a half. And of course, your y-intercept would be 5. Now for part 3, they want us to determine the equation of line 2, which is L2. Now in order to write the equation of the line in the form y equal mx plus c, you need 2 things, the gradient m and the y-intercept c. Now if we go back here, we have the gradient of L1 is equal to negative a half. And seeing that line 2 and line 1 are perpendicular, so I'll just put this in here. I'm going to put m for L1 and call that M1 is equal to negative a half. And for line 2, I'll call this gradient M2. Seeing that they are perpendicular, when you multiply M2 and M1, you're supposed to get negative 1. So in other words, the gradient for line 2 would just be negative reciprocal of the gradient for line 1. So if you flip a half and change the sign, you'll get positive 2. So the gradient for L2 is positive 2. So again, if two lines are perpendicular, if you multiply two gradients, you're supposed to get negative 1. So you can see 2 times negative a half would give you negative 1. And the easier way to do it is simply saying, okay, once you know the gradient of one line, just take the negative reciprocal of it. Flip and change the sign. All right, so you flip a half and get 2, change the sign from negative to positive. And that's your perpendicular gradient. So I'm going to come here and put the gradient of line 2 is equal to positive 2. All right, so therefore, I'm going to put m is equal to 2. So we have one part so far. We have the gradient is 2. Now we need to know what's the y-intercept for line 2. And now if we go back here and look at line 2, we can see that the line touches the y-axis at 0, negative 5, which means 0 on the x-axis, all right, but negative 5 on the y-axis. So therefore, C is negative 5. All right, so I have from the graph, we have C is equal to negative 5. So if I write the form y is equal to mx plus c, I replace the m with positive 2 and the c with negative 5. Of course, you multiply these two signs and you'll get a negative sign. So you'll have y is equal to 2x, take away 5, and this will be the equation of line 2. All right, so I have the equation of L2 is y is equal to 2x, take away 5. Now moving on to part B, we have the functions f of x is 1/3 x plus 4 and g of x is 3x over x plus 1. Now for part 1, we want to determine what is f of 9. So we'll take the function f of x and replace the x with 9. So for part 1, we have f of x is equal to 1/3 x plus 4. And of course, we're replacing that x with 9. So we're going to have f of 9 is equal to that 1/3 x. And of course, we're replacing that x with 9, which means 1/3 multiplied by 9 plus 4. Now, if you write out what that means, 1/3 multiplied by 9, which would be 9 over 1, plus 4, we can see that we can have 3 into 3, 1, and 3 into 9, 3. So 1 by 3 is 3, 1 by 1 is 1, so that's 3 over 1, which is just 3. All right, so we're going to have 3 plus 4, so the answer will be 7. So f of 9 is equal to 7. So for part 2, we want to calculate the value of f, g of negative 3. So what we can do first is find out what is g of negative 3. So that means we'll be substituting negative 3 into the function g of x. So first I'll write out g of x is equal to 3x divided by x plus 1. And I would be replacing the x with negative 3. So I have 3 times x, which would be 3 times negative 3, over x plus 1, which would be negative 3 plus 1. So 3 times negative 3 is negative 9. So that'll be equal to negative 9 divided by, and negative 3 plus 1, you'll get negative 2. So negative 2. And of course, if you divide two negatives, you're going to get positive. So this will just be equal to 9 over 2. So that'll be g of negative 3. Now I'm leaving this as an improper fraction because now I have to substitute this number, 9 over 2, into the function f. And would be better to work with if it's an improper fraction. So now I'll write f g of negative 3 is equal to f, I'll put some brackets like this, g of negative 3 like this. So that simply means I'm replacing this g of negative 3 with what I got here as 9 over 2. So this will be equal to f of 9 over 2. So this will mean that I'm replacing the x in the function f of x with 9 over 2. So the function f of x is 1/3 times x plus 4. So I'll have 1/3 times 9 over 2 plus 4. So instead of 1/3 x plus 4 is 1/3 times 9 over 2 plus 4. So now we can cancel this 3 and 9. We can say 3 into 3, 1, and 3 into 9, 3. And now 1 times 3 is 3, and 1 times 2 is 2, so that'll just be 3 over 2. All right, so this will be equal to 3 over 2 plus 4. Now 3 over 2 is 1.5, so that's 1.5 plus 4. So that'll just be 1 plus 4 is 5, so that'll be 5.5. So the answer will be 5.5. So f g of -3 is equal to 5.5. Now if you wanted to do that on the calculator as the 3 over 2 plus 4, could I use the fraction button and say 3 over 2 like this, and then add the 4, and you can see you get 5.5. Now for part 3, we have determined the value of x for which g of x is equal to 5 over 2. So let's write the function g of x being equal to 5 over 2, and g of x is this 3x divided by x plus 1. So what we'll have is g of x being equal to 5 over 2 would imply the 3x divided by x plus 1 is equal to 5 over 2. Now we can use a method of cross multiplication here with the 3x multiplied by 2. I'll just write it out as 3x times 2 like this, so there's no confusion. And then we'll have the x plus 1 multiplied by 5. And I'll write that as 5 times x plus 1. So if we multiply the 3x by 2, we get 6x. And if we multiply the 5 by x here, we get 5x. And 5 by positive 1, we get positive 5. Now we bring the x's together, so I'll bring this positive 5x across on this side, and turn to negative 5x. So I'll have 6x take away 5x is equal to 5. And 6x take away 5x is 1x, which is the same as x. So you'll get x is equal to 5. And that's the answer. Now moving on to question 4 for June 2019, we have the quantity p varies inversely as the square of v. So using the letters p, v, and k, of course k will be a constant of proportionality, we want to form an equation connecting the quantities p and v. So first we'll write that p varies inversely, so we write the proportional sign, and inversely mean 1 over, all right, and the square of v, so that's v squared. Now if it was p varies directly as v squared, you'll write p varies directly as v squared like this. Now because it varies inversely, that's why we have the 1 over v squared. So now to go from the proportional sign to an equal sign, we have to introduce our constant of proportionality. So we'll have p is equal to k times 1 over v squared, where k is your constant of proportionality. And that's your equation with p, v, and k. Now what you can do to further simplify this is recognize that this will be k over 1 multiplied by 1 over v squared. So what you'll get is k over 1 multiplied by 1 over v squared. So the k times 1 will be k, and the 1 times v squared will be v squared. So you'll have p is equal to k over v squared. So now for part 2, we have given that v is equal to 3 when p is equal to 4. We want to determine the positive value of v when p is equal to 1. Now the first thing we'll do is use this v is equal to 3 when p is equal to 4 to find what is our constant of proportionality, k. So I'll write when v is equal to 3, p is equal to 4, I write p is equal to k over v squared. So now I replace the p with 4 because p is equal to 4, and this v here with 3 because v is equal to 3. So I'll have 4 is equal to k over 3 squared. And of course 3 squared is 9, so we'll have 4 is equal to k over 9. I'll cross multiply, so I'll put 4 over 1 is equal to k over 9. So that'll be equal to 1 times k will give you k. And 4 times 9 will be 36. So now I know K is equal to 36. So when I have P is equal to K over V squared, I can replace that K now with 36. So I have 36 over V squared. So now we want to find the positive value of V when P is equal to 1. So I'm going to write when P is equal to 1, we want to find out what is V. So we have P is equal to 36 over V squared. And of course, P is 1. So we have 1 is equal to 36 over V squared. So I'll simply write that as 1 over 1 is equal to 36 over V squared. So if you multiply 1 times V squared, we'll just get back V squared. And 1 times 36 would be 36. So now V will be plus or minus square root of 36. And now seeing that the question said that they just want the positive value of V, I don't need to include the negative value of V. All right, so plus or minus square root of 36, the answer would have been plus or minus 6. So I'll just be taking the positive value only. So V is equal to positive 6. Now moving on to part B1, we have given that x is a real number, solve this inequality. So we have 3x plus 5 is greater than negative 7, and then 3x plus 5 is less than or equal to 7. So I can write that as 3x plus 5 is greater than negative 7. That is this part here. See, the big side by the 3x plus 5. So 3x plus 5 greater than negative 7. So that's why I wrote here. And we have 3x plus 5 is less than or equal to 7. So these are two separate inequalities that I'm going to solve. So standard thing, we're going to bring the positive 5 across the inequality sign. I will turn from positive to negative. So we're going to have 3x is greater than negative 7, take away 5. Of course, the two signs are negative here, so you just add and keep the negative sign. So 7 plus 5 is 12, so that's negative 12. So we have 3x is greater than negative 12. And now we'll transfer this 3 across the inequality sign, and it's 3 multiplied by x. When go across, the operation will change to division. So we have x is greater than negative 12 divided by 3. So x is greater than, of course, I divided a negative number with a positive number, so your answer is going to be negative. And of course, 3 could go into 12 4 times. So your answer will be x is greater than negative 4. So now same thing for this one, transfer the positive 5 across and I'll turn to negative 5. So we have 3x is less than or equal to 7 take away 5. So 7 take away 5 is 2, so we have 3x is less than or equal to 2. Since this is 3 multiplied by x, when we transfer 3 across the inequality sign, the operation will change to division. So we have x is less than or equal to 2 divided by 3. And these are your answers. X is greater than negative 4 and x is less than or equal to 2/3. So for part 2, they want us to represent our answer in B part 1, which is this, on this number line. So let's put in some numbers here. I need to cover negative 4 to positive 2/3. So let's go up to like positive 1. So here I have my number line labeled. Since this is 0, I have my negative numbers on the left-hand side, and of course my positive numbers on the right-hand side. Now, seeing that the two numbers we're dealing with is negative 4 and 2/3, I'll put some circles where negative 4 would be and 2/3. So that's estimating the 2/3. So that'll be about here. And now seeing that x is greater than negative 4, and we do have an equal sign on it, this circle remains unshaded. And seeing that x is less than or equal to 2/3, the circle by 2/3 will have to be shaded. So I'm going to shade the circle by 2/3. Now I'm going to draw a line to connect these circles. And now remember, more than is going to the right and less than is going to the left. So seeing that x is more than negative 4, from the negative 4, we have to go more than, which will be going to the right. So I'll put a little arrow going to the right like this. Now see that we have x is less than or equal to 2/3 and less than is going to the left. So with the circle with 2/3, we're going to the left. So I'm putting an arrow going to the left like this from the 2/3. And that will be representing your answer on the number line. Now I just want to discuss an alternative way of working this. We could have written -7 less than 3x plus 5, which is greater than or equal to 7. So in order to get rid of this positive 5, we have to take away 5. So you'll do that here, here, and here. So we'll have -7, take away 5, which is less than 3x plus 5, take away 5, which is less than or equal to 7, take away 5. So you see I'm keeping things balanced by doing the same thing on both sides of the inequality sign. Alright, so of course 5 take away 5 is 0. And this -7 take away 5 is a -12. So we have -12 is less than, of course the 5 take away 5 is 0. So all we have here is 3x, which is less than or equal to 7 take away 5 is 2. Now to get rid of the 3 here, I'll have to divide by 3. So that means I have to divide throughout by 3. So I'll have -12 divided by 3, which is less than 3x divided by 3, which is less than or equal to 2 divided by 3. And of course, the 3 will cancel the 3 and give you x. And 3 into -12 is -4. So we're going to have -4 is less than, of course, 3 cancels 3 and you get x, which is less than or equal to 2/3. So this simply means x is greater than -4 and x is less than or equal to 2/3. So x is in between -4 and 2/3. And the number line shows that x is in between -4 and 2/3. Now moving on to part C, we have the equation of a straight line is given as x over 3 plus y over 7 is equal to 1. This line crosses the y-axis at Q, and we want to determine the coordinates of Q. So if it crosses the y-axis at Q, it means Q is the y-intercept. And to get the y-intercept, x must be equal to 0. So I'll put when x is equal to 0, we'll have x over 3 plus y over 7 is equal to 1. Replacing x with 0, so we have 0 over 3 plus y over 7 is equal to 1. Any fraction of 0 as a numerator is 0, so that's 0 plus y over 7 is equal to 1. So that's just y over 7 is equal to 1. And I'll put that over 1 time. And if you were to cross multiply, y times 1 will give you y. So I'll have y is equal to, and 7 times 1 is 7. So y is equal to 7. Now remember, they want the coordinates of Q. So the coordinates of Q will have an x component and a y component. So the x component is 0 and the y component is 7. So I'll have the coordinates of Q would be 0 and 7. So for part 2, they want to know what is the gradient of this line. And to find the gradient of this line, we need y as the subject of the formula, and then we can determine the gradient. So we'll have x over 3 plus y over 7 is equal to 1. And I'll write that as 1 over 1 time. What I'll do here is find the LCM. So I'll have the LCM between 3, 7, and 1 would just be 3 times 7 is 21. So 21. I'll say 3 into 21 is 7. 7 times x is 7x. Plus 7 into 21 is 3. 3 times y is 3y. Is equal to. And 1 into 21 is 21. 21 times 1 is 21. And now we drop the LCM. So we simply have 7x plus 3y is equal to 21. So all we did so far is change the form of the equation of the line. So now we could go about transposing for y. So I'll transfer this positive 7x across the equal sign. I'll turn to negative 7x. So we'll have 3y is equal to 21, take away 7x. Seeing that this 3 is being multiplied by y, when I transfer it across, the operation will change to division. So I have y is equal to 21, take away 7x divided by 3. Now I write two terms in the numerator over the common denominator. So I'll have y is equal to 21 over 3, take away 7x over 3. Now 21 over 3 is 7, so that's 7, take away, and I can write this as 7 over 3x. Now as long as y is the subject of the formula, whatever number is in front of x would be your gradient. So negative 7 over 3 is in front of x, which is the coefficient of x. So your gradient is negative 7 over 3. Now I'll just rearrange it so it will be in the form y equal mx plus c. Alright, so I'll just write it as y is equal to negative 7 over 3x plus 7. So we have it in the form y is equal to mx plus c. Alright, so here we can see that m is negative 7 over 3. I can write that as a mixed number, and that'll be negative 2 and 1/3. And you can see c would have been 7, which is your y-intercept, and you see we get our y-intercept here as 7. And that's it for this video.